We have some new concepts that are going on. Wolf, go ahead and stop writing. You can come back to it later. Okay, first example. What type of math is this right here, do you think?
Division.
Yeah, because it's a fraction. It doesn't matter that there's a variable there, okay? So what happens in a situation like this, when you have a variable up here, is that we're going to multiply, right? Because multiplying is the opposite of dividing. So we're going to multiply both sides by -5. That's going to get the k by itself. Are we clear? Now, it doesn't matter if the k is on the bottom or it's on the top. It's the same exact thing, okay? This also right here, that's like a fraction next to a variable. We'll cover that one in just a second. But doesn't matter what the variable is. It can be any letter, right? We know what a variable is?
Yeah.
It's a what? Very good. Okay. So we multiply both sides. What is a negative times a negative?
Positive.
Okay. So -5 times 4 is positive 20. So our answer is k equals 20. These are our rules. We work on the variable side. What side is the variable? We do the inverse operation. What does inverse operation mean?
Like multiplying divide.
Yeah, the opposite. So if it's subtraction, we do addition. However, that normally doesn't happen since we're dealing with multiplying and dividing. And the last thing is, what we do to one side, we have to do the other. Aren't these the same exact rules that we covered in addition and subtraction? Same thing we covered yesterday and Friday. Same exact rules. There's only two things that are different that happen in this section. Okay, let me see thumbs up or down on this one. Okay, fraction, right? Division. The opposite is multiplying. So we're going to multiply by 5. Do you want to see why it is that we do that? Sure, Mr. Peters. So if we're -5 over 1, okay, and we multiply by 5, there's a 1 underneath here, right? It's the same thing as 5. If we multiply this, what's our answer? 1. What's in algebra when we have a variable that we can't see? A 1. So there's something, always a value of at least 1. And that's why multiplying by 5 on both sides cancels this out and gets the k by itself. So, fraction, we're multiply both sides by -5, multiply these out, k is 20. Do you understand?
No, wait. So the K, we're just putting a 5 on top, the number under it?
Because this is a fraction, what's the inverse operation? What's opposite of dividing?
Multiply.
Multiplying. That's why I'm multiplying the 5. I obviously can't multiply the k, right? Because I don't know what it is, right?
Is it a 1?
How can you count multiply 4 by 5?
We did, in the end. Oh, how can we move it the other side? That's a good question, Wolf. Because we always work on the variable side. Because we're trying to solve for the variable and get the variable by itself. That's an excellent question. Okay, so multiply both sides by 5, k equals 20. Any questions on this one?
No.
No?
I don't know.
Okay, stand up for me real quick.
No, I just.
No, it's okay. Stand up for me real quick.
Why?
Just stand up for me real quick, please.
No, you're gonna record me.
I'm already recording. Stand up. And I can't see you. Mercedes, stand up real quick.
Oh.
Okay, next one. Mercedes, there's nothing really to get. It's a fraction. Undo it. Divide. Same thing we were doing yesterday. No different. Okay? You're just following these rules. Coming to this one. Wolf, your moment to shine, buddy. What type of math is this right here?
Division.
Division. So we're going to multiply, right? So pretty much the same thing here, right?
What did you say?
We're going to multiply 3 by both sides, and 1.5 times 3 is? Yep, that solves it. Okay? Now notice,
We can do it.
yes, we work on the variable side, which is the m, right? That's division. So we're going to multiply by 3. Okay? We multiply both sides by 3, that gets the m by itself. 1.5 times 3 is 4.5, right? If you want, put it in your calculator if you need to see it.
No, if you said 3 times 3, that's what I am.
Yes, do you want me to show you why?
Yeah.
Okay. So see how this this 3 and this 3, this 3 is at the bottom, right? So if m has at least a value of 1, it looks like this, 1 over 3, right? So us multiplying by 3 is essentially the same thing, because what goes under a whole number when we can't see it?
1.
Very good. So we multiply this across. 3 times 1 is what?
3 also.
And 3 times 1 is what?
3, so it's 1.
Right. So every variable has at least a value of 1, right? That's why we do it. That's how it cancels out. You see it? Okay. Well, good thing is, if you just follow the rules, you're good. Okay? So, m over 3, it's a fraction. We're going to take the number, we're going to multiply both sides. This cancels out, gets the m by itself, and then we multiply the 1.5 times 3. Rice, let me see your eyes, please. Okay.
So much big.
Yes.
Okay, so basically the denominator, you're always going to put it on the other side, on each side.
Yes. Yeah. Because if we're going to get there in a minute.
So and basically the whole would cancel the whole thing out.
Yeah. Yeah. Because if it's 1, remember, it has to have something, some type of value, right? We just don't know what it is. But in algebra, we know it's at least 1, no matter what.
So can you, wait, when
We'll
we're
get,
done with,
ignore this right now, we'll get there in a minute.
I know, when we're done with that, can you, like,
Yes, we'll go through it, and I'll show you, I'll tie it back to the examples. Yes. Okay, are we good on both these? Let me see thumbs up or down on this. Okay, so fraction, multiply. Fraction, multiply, right? So we're good so far?
so next when we multiply them,
Yeah. Well, we're going to cover this first. What type of math is this right here? Yes, this is just like 7 times x, or 7 parentheses in x. Anytime we have a constant next to a variable, it means multiply. What's the opposite of multiplying? Divide. So we're going to divide this by 7. It's going to get the x by itself. We put this in the calculator. Well, 56 divided by 7 is 8. So we just, it essentially is the same exact thing. Multiply, opposite divide. Division, multiply. Division, multiply. These 3 rules. These are the same rules we did yesterday. Okay. This is what's important. Okay? Always work on the variable side first. It's the number 1 mistake I see. I see trying to solve for the 1.5, solve for the 4. You can't do that. You want to solve on the variable side first. Okay?
What side is the variable?
The side that has a letter on it.
So for D, the variable side would be,
It could be on whichever side.
Not necessarily.
Huh?
That not
That's what you said last time.
what side is the variable on over here?
the left side.
Yeah, the left side because of the V,
Yeah,
right?
can it be on the right side too?
It can.
Oh, yeah, it could be on.
What he means is the variable can be on the left or it can be on the right. He's right. However, Mercedes is right too because she said we always work on the variable side.
Yeah.
So you're both. Yeah.
Both right.
Okay, good. Glad we got that established. Okay. This one's super important, and it's why we have this rule here. Okay? We have a fraction next to a variable, right? Remember what we had up here. We had a number. Wilson, I need to see your eyes. We have a number next to a variable. This means multiply, right?
Yes.
When we have a fraction next to a variable, we follow this rule. This is why I had you write this down. What does the reciprocal mean?
Opposite.
What does it mean, though, at the end of the day? What do we do to the fraction? Very good. Flip it. So you see how this is 5 over 9. We're going to flip this over and do 9 over 5. Okay? What we do to one side, we do to the other. Now let's talk about this for a minute. Isn't this the same thing as this?
Yes.
It is. It's 9 times 5 and 5 times 9. It's 1. Right? Okay? So once we do that, we move it to the other side, right? Well, help me out here. What do I have to do with this 35?
You put a 1 under it, sir.
Very good. Rice, plug that in, sir. Wilson, I want to see your eyes. Rice, come on, dude. Okay, So Wolf, yeah, we're going to put a 1 underneath this, right? Now we're going to cross cancel because 5 goes in 35, doesn't it?
Yes.
Yeah. 5 times 7 is 35. So we cross out the 5, we put 1 because 5 goes into 5 one time. And then 5 goes in 35 7 times, right? So now that we have that done, we multiply across the top and across the bottom. So 7 times 9 is 63, and 1 times 1 is what?
1.
Very good. And are these two numbers the same thing?
Yes.
They are. We don't write it this way, it's simplified this way. Any number under 1 doesn't matter anymore. Chris, you need to plug in and stay with me. I'm going to stop just for a minute, okay? Because I'm noticing something. Okay? You guys, some of you in this class, and some of you had me before, are making this way harder on yourself than it needs to be. And I'm just being straight up. Like if this doesn't get fixed, you're going to be back here next semester. Because there's no one else, right, Wolf? I'm it. I'm it. You can't take it with someone else. And I spoon feed it. So this is your opportunity. Can we get back? Okay. Back to this. So, Mercedes, I actually wrote this out because sometimes it's hard to see it because the numbers are larger. 9 times 5, 45. 5 times 9, 45. So it's 1, right? And 1 cancels out because when we have the variable, it has at least a value of 1. So that's why we do it to one side to the other, and that's why we flip it over. If we didn't flip it over, our numbers would be way off. Right? Okay. So 63 over 1, same thing as 18 over 1 or 18. We're done at 63. B equals 63. Do we understand why? Well, what's 7 times 9? That's all one problem.
Can you do it one more time, please?
Sure. Fraction next to a variable, we're following this rule. Okay? We're going to do the reciprocal, which means we're going to flip over this fraction. Okay? This is going to cancel out. What we do to one side, we do to the other. Well, you got this because you enough times, right? We have to drop 1 underneath there, right? Because we want to multiply the top by the top and the bottom by the bottom, right? But we can reduce these, can't we? Because 5 goes into 35, so we can do what we call cross cancel or reduce, right? So 5 goes into 35 7 times, and 5 goes into 5 one time, right? So from here, we multiply the top by the top, 7 times 9, which is 63, and 1 times 1, which is 1. Does that part even matter? It doesn't, because it's 1, right? Yep. And we'll actually do another one together. Okay, let's look at this one right here. Don't get confused. If you have a variable next to a number, this is still a fraction next to a variable. Okay? We're still going to do the reciprocal of this. We're going to work on the variable side. So we're going to take this 4 over 3 and we're going to flip it over. We're going to multiply both sides, then we're going to multiply the other side. Now I have a question. Can I reduce that?
No.
I can't. None of those numbers go into each other. So then from there, I'm going to multiply the top by the top. 5 times 3 is 15, and 4 times 2 is 8. Now plug in with me because I know some students get super confused of how to do improper fractions.
Wait.
First of all, how do I know this is an improper fraction?
The numerator is greater than the denominator.
Very good. Okay, I actually write the physical steps out. This is how we do it. Everyone put your calculator on your desk.
Wait, Mr. Petey,
Not yet, not yet. Okay, take 15 divided by 8 and tell me what the answer is. Wilson, your time to shine. Go. 15 divided by 8. We'll wait for you. Calculate. 15 divided by 8. I want to know the actual number. Mercedes, do it please.
1.785. No, 1.875.
I'm waiting for Wilson. I didn't hear him. I couldn't hear him well enough. Okay, this is what I wanted to burn in your brain. Ignore the decimal. Okay? It went in one time, right? Okay, that's our whole number. 15 divided by 8 is 1 decimal. We're not concerned about the decimal. Okay? Because we want to leave things in fraction form. Okay? So then, what is 8 times 1? 8. So we take 15 minus 8, which is 7, right? Stay with me. Stay with me. This is our numerator. Okay? We're going to do a couple of these together. So this becomes our numerator. I don't do anything with the denominator. Wolf, I think it's your moment to shine. Okay? Yeah, it is. if I have 12 over 5, let's turn that back proper. Tell me how to do it.
One, okay.
Yeah, can I give you one, but give her one first? Okay, go.
2 and 2/5.
Okay, and tell me how you got it.
So 5 goes, like 5 goes in 2 times and then the rest.
Not gonna be.
Okay, so Wolf, watch this. She took 12 divided by 5, which is 2. The decimal, we're not concerned with the decimal. Right? Do it on your calculator. 12 divided by 5. Okay? So we're focused on the whole number, right? So we take 12 divided by 5, which equals 2, right? That's our first thing. Okay? Now we're going to multiply that. What's 5 times 2? It's 10, right? What's 10 from 12?
See, that's the confusing.
Which part? You want me to give you another one?
Well, it's
What
the
about the point
confusing
one?
way.
What about the little point five?
What did I tell you to do with the decimal? What did I tell you to do with the decimal? Class, what did I say to do with the decimal?
Forget it.
Ignore it. There you go. Okay.
This is what I.
Oh, God. Do you really want to hear it? No, we don't. Okay. All right, Wolf. You're going to do one for me, okay? You got this. 15 over 7. Tell me how to put that back proper.
Oh my god.
Shh. Let Wolf do it. It's his time to shine.
Yes, it's my turn. 2.
2. Okay. And what is 7 times 2? And what's 14 minus 15? So that's my numerator, right? What's my denominator? Excellent. You got it.
That's it.
That's it. Any questions? Should I go through it one more time?
How do you get
I got it.
Go over it.
7 times 2 is 14. So when we take 15 divided by 7, we get 2 point something, 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 right? And Wolf said we do something with that decimal. What do?
forget about it?
We ignore it. We ignore it.
Because if you do 7 times 3, it's 12 and 15.
Yeah, and then our numbers wouldn't be right? Yeah. Wolf, you got it?
Yes.
Okay. Oh, by the way, a little fast forward. Watch this. This is how we turn it back proper.
7 times 2 plus 1.
Yes. 7 times 2 plus 1. 14 plus 1, 15 over 7.
Sugar, awesome.
Hey. Okay. Any questions so far?
No.
Yes, go.
Can you do one more?
Yes, we can do one more. It's your time to shine.
Oh,
Can
no.
you do it now?
No, you got this. I'm gonna help you. No, not yet. I'm gonna help you, but I'm gonna give you a super easy one. You're
Can I
gonna be
shine one
pumped.
more time?
Yes, Wolf.
Is
Okay,
it-
ready? You got this, I swear. I know. Ready? 3 over 2.
3 divided by 2.
Okay, which is what?
1.
Okay, what's left over? What's my numerator?
3.
What's 3 subtracted by 2?
1.
Okay, what's my denominator?
2.
Good. Is that correct? You want to do one more? Okay. What's my whole number?
1.
Good. What's my numerator?
5.
What's 7 from 5?
Divided
Subtracting.
on
Okay. What's my denominator? You got it. It's Wolf's time to shine. Can I give you kind of a different one? He's like, huh? Okay.
2. Can I shine now?
Yes, and then we're going to move on. All right, Wolf, buddy.
I still divide, right?
Yes, sir. Rules never change.
Divide, oh, here we go. 1, 2. 3.
Okay, what's left over? What's my numerator? What's my numerator? Hmm?
What I do again, I subtract, right?
Okay, so you divided, right? Now you want to multiply. What's 7 times 3?
7 times 3 is 21.
Okay, and what's 21 subtracted by 22?
1,
Good. What's my denominator?
7.
Good. You're right.
Alright, 21.
Yes, I think you guys got this.
Tony?
Okay. Oh,
No,
Mercedes,
no,
I'm
no,
sorry.
no, we're done
I'm sorry.
shining. We're done shining.
All right, well, can we let her shine just a little bit? She doesn't get many opportunities there.
You're such a hater.
Okay,
She's good. We need to move on.
okay, Mercedes.
It's all 41.
1 and 1 now.
Okay, watch it. Watch this.
Just shining.
Watch this. Okay.
It's all 55.
Wilson, look up. Do this one for me.
You get it? Easy one.
Me?
Oh, yeah. Yeah, your name's Wilson.
Oh, good.
How come?
No,
Okay.
it's like 3, 2. Yeah, yeah. You get 1
Okay, and what do we have left over?
on 1.
Okay, and what's the denominator? Good. Okay, I want you to do one more for me. You do get this. Okay, go. Okay, and what's left over? What's the numerator? Okay? What's the denominator? You do get this. Good job. Okay, where did we leave off at? So we covered this, right?
No.
Okay, let's go down, let's go to D now. Now I want to show you something with D. Do you see this right here? Well, what type of math is this?
Multiplication.
Right, so we're going to divide to solve for it, right? Is it safe to say that that problem's the same?
No.
You sure? Is this problem the same? It's exactly the same.
Which one? Which one?
Yeah. Don't let that throw you off. That's still -2 multiplied by W. How do we solve for it? Divide by -2, divide by -2, right? Isn't this an improper fraction? Yeah, so we need to turn back proper, right? Well, positive divided by negative, what's my answer? Is it positive or negative?
Negative.
Very good, it's negative. So I take 13 divided by 2, which is 6, right? And then 12 minus 13, which is 1, carry the denominator over. This problem is identical to this problem. The only thing that's different is the negative. And our brains play tricks on us because we see the x on this side, we see the w on this side, and we say, I don't know how to solve that. Well, you do know how to solve it. Do we see that? Now you're going to see the same thing happen in the do now. Okay, so we covered D. All right, let me see if we've got this, or is there anyone I need to go over again? Okay, if you have a fraction next to a variable, how do you solve for it?
Flip it.
And what do we call that?
Reciprocal.
Very good, very good. What happens when we have a fraction that there's a variable in it? Wilson, pull your hoodie off, please. Yes, I have rules.
Multiply.
Because this is division, right? So we multiply to get rid of it. If you get stuck with this, remember this. We're trying to get it to 1, that's why we do the reciprocal. Okay? All right, let's look at the do now. Look at this problem right here. Isn't this the same?
Uh-huh.
It is. Look at this one right here. Isn't this one the same? The only thing that's different is we have a fraction, right, Wolf?
Yes, sir.
So we're going to do the reciprocal on this side. We're going to do it on this side, and we're going to multiply the... You time to shine, buddy. We're going to multiply the...
The top by top and bottom by bottom.
Yes! That's absolutely correct. Isn't this one the same thing as C?
Yes.
It is. What about this one right here?
Yes.
Yeah, right? This is a fraction. Multiply both sides by 3, right? This one right here. What do we do here? What type of math is this?
Division.
Okay, this is a fraction, right? Next to a variable, right? So what do I do to this?
Multiply.
Mercedes, help me out. I have a fraction next to a variable. What do I do? Go, Ruben. Yes! Well, flip it over. Okay? What you do one side, do to the other. Yes. What about this one right here? And it's the same thing. We have a fraction next to a variable. Flip it over, multiply the other side. What type of math is this?
Multiplication.
Yeah, how do we solve this?
Multiply. Put a 1 under.
It's multiplying. How do we solve this one right here?
Divide.